Hello everyone, here's J Square. So this video will introduce logarithm and exponent. So first of all, let's review what's the definition of exponent. So the original exponent is like, for example, a to the power of n. It means n amount of a multiplied together. Then some of you guys will ask me, so JJ, it's not make sense. If a to the power of n, it means n amount of a multiplied together. So how can a to the power of negative 2 or a to the power of 1 over 2 make sense? So right now I can prove how to make them make sense or why it makes sense. So before everything, I have to make sure that you guys know that a to the power of b, then to the power of c, it is equal a to the power of b times c. Right? Why is that? Because think about it. So a to the power of b is b amount of a multiplied together. Then a to the power of b to the opposing to the power of c is c amount of a to the power of b multiplied together. So in total, we have b times c amount of a multiplied together. Therefore, this formula makes sense. Okay? So, right now, we don't know what is a to the power of 1 over 2 means, so we can do that. We can let a to the power of 1 over 2 equal x. Then we square both sides. So a to the power of 1 over 2 to the power of 2 is equal x squared. So use this formula. A to the power of 1 over 2 then to the power of 2 is equal a to the power of 1 over 2 times 2, which is equal x squared. So a is equal x squared. Therefore, x is equal square root a. We can do same thing because no matter it's a to the power of 1 over what, for example, 1 over 3, we can use similar method to prove that a to the power of 1 over 3 is equal cube root of a. So we can have this formula that a to the power of 1 over n is equal n's power root. Does that make sense? Then let's prove a to the power of negative something, for example, a to the power of negative 2. So according to this formula, we know that a to the power of negative n is equal a to the power of negative 1 times n, which is equal a to the power of negative 1 then to the power of n. So if we know what is a to the power of negative 1, then we can figure out a to the power of negative anything. So what is a to the power of negative 1? I have to make sure that you guys also know this formula, that a to the power of n times a to the power of n is equal a to the power of m plus n. So a to the power of m is n amount of a multiplied together. A to the power of n is n amount of a multiplied together. Therefore we have a to the power of n plus n. If we let n plus n equal x, and then we move a to the power of n to this side, so it's like a to the power of x divided by a to the power of n is equal a to the power of n. Does that make sense? I divided a to the power of n for both sides, then we get this because I let x equal n plus n. Then Because m plus n equal x, therefore m is equal x minus n. So we can get formula that a to the power of x divided by a to the power of n is equal a to the power of x minus n. This formula is really important. For example, we know a to the power of 3, right? So we let a to the power of 3 divided by a to the power of 4. According to the formula we get it there, we know that it should equal a to the power of 3 minus 4, which is equal a to the power of negative 1. For the left side, here's a to the power of 3, here's a to the power of 4. So cancel that out. Then it's equal 1 over a. So we know that a to the power of negative 1 is equal 1 over a. So a to the power of negative n is equal 1 over a to the power of n, which is equal a to the power of n, 1 over a to the power of n. So it is some basic exponents definition or basic exponents property, and yeah. I want to introduce the inverse operation of exponents, which is logarithm. So if a to the power of x is equal to b, then log base a of b is equal to x. So it's like if I know a as base and the power, then I can calculate b. So it's like if I know the base a and the result b, then I can calculate the power. So that's why they are inverse operation. So there are 4 important formulas for logarithm. First one, log base a of x times y is equal log ax plus log a y. We can do that. We let p equal log ax. We let q equal log ay. Therefore, what can we know? We know that if p equal log ax, it means a to the power of p equal x. And same, a to the power of q equal y. So x times y is equal a to the power of p times a to the power of q, which is equal a to the power of p plus q. Then we use log. So log a xy is equal to log base a of a to the power of p plus q, which is equal p plus q. So we know that p is equal log ax, q is equal log ay. Therefore, we know that it's equal to log ax plus log ay. So that's why this formula is always correct. Then we can use similar method to prove this one. We do same. So p is equal, this one equal p. This one equal q. So everything is same. A to the power of p is equal x. A to the power of q equal y. So x over y is equal a to the power of p divided by a to the power of q, which is equal a to the power of p minus q. So we use log base a again, then log a is equal log base a of a to the power of p minus q, which is equal p minus q. Obviously is equal log ax minus log ay. Those two formulas are similar to each other. It's because division is the inverse operation of multiplication, and the minus is the inverse operation of plus. And also, x over y is equal x times 1 over y. We can think 1 over y is an individual number. Then we can put this thing in the first formula. Then we can get this. Right now, we just have to prove or understand why log a 1 over y is equal to negative log a y. For example, 2 to the power of 3 is equal 8. So that's why 2 to the power of negative 3 is equal 1 over 8. So we can think about it. So if log a y is equal q, so it means a to the power of q equal y. That's the thing we know. But we also can know that a to the power of negative q is equal 1 over y. So we know that if log a y is equal q, therefore log a 1 over y is equal negative q. So I can write it down. That's good. Formulas. Then let's prove last two formulas. So basically this one is same as this one. Why I say that? Because x to the power of n is n amount of x multiplied together. Therefore, x to the power of n is equal x times x to the power of n minus 1. According to the first formula, we know that it's equal log a x plus log a x to the power of n minus 1. Then we can use the same method to expand this term. Then continue. Then in total, we can get n amount of log a x plus together. So this one is same as this one. Actually, same as this one. It's just special case that x is equal y. Here's many same number multiplied together. Then we just use first formula to expand it, then add it together. Then we can get this equation, this formula. This one is really complicated, so focus and pay more attention, then make some note. Follow my step. We can use same method. Is that log base x of y is equal log base a of y divided by log base a of x. So we can let log x y equal OPQ. So this one is equal O. And this term is equal P. This term is equal Q. Then we can know that, sorry, wrong pen, x to the power of O is equal y. Then we can know that a to the power of p is equal y. Oh, this q is so bad. I'm not good at writing q. So a to the power of q is equal to x. shouldn't use letter O, but it's fine. Or let's draw something inside. O plus. So we can put x and y in the first formula. So we know that a to the power of q, then to the power of, I don't know what is this, O plus is equal to a to the power of p. Then we know that a to the power of q O plus is equal to a to the power of p. Then let's use log a So at the end, we can know that Q O plus is equal to P. I will move this formula to here. So we know that QO plus is equal to P. Therefore, we know that O plus, oh my god, is equal to P over Q. So O plus is equal to this, P is equal to this, Q is equal to this. So you get it, right? I mean, yeah, it's a final, we just need to put this three things back to the formula we already proved, then we can get this formula. You guys can check my step. I didn't use the result as the condition to prove everything. It's not like because of A. It's not like because A, then A. So I didn't know this at the beginning. I just assumed this, right? So then I have many steps. After those steps, I prove the thing we need. So we get the formula. How, I mean, why we need this formula? Because sometimes we don't know how much is log base x of y, but if we know, no matter which base a, if we know log ay and log ax, then we can use this formula to calculate log xy. So that's all. It's all the four formulas we have, and it's the way to prove it. So it's really interesting, right? I hope so. So let's solve a question. If you are my classmates, then probably you guys still remember this question. So the question wanna ask how to use B to express A. So first thing we should do is move 1 over 2 to this side, which means times 2 for both sides, so we can get, I mean, you can keep 1 over 2 to here, but I mean fraction. I actually, if you have equation, then try to let fraction disappear, Because, for example, in this case, log. If we just use 10 to the power of something to cancel the log, then this side you have 1 over 2, which means square root. It's not convenient. So that's why I do this step. So after that, 10 to the power of 2 log 1 over 2 times square root of 2, then times a plus 2b is equal to 10 to the power of log a b. Therefore, we know that it's equal 10 to the power of log those whole thing 10 to the power of 2. And this side we know that is equal to AB. Then we know that 1 over 2 times square root of 2 and A plus 2B whole thing to the power of 2 is equal AB. Then square root, then we know that right? Then 1 over 8 times A plus 2B to the power of 2 is equal AB. Then here's 1 over 8, a fraction again, so let it disappear. So A plus 2B whole thing squared is equal 8AB. And now let's expand this thing according to the binomial expansion. I explained it last video. So a squared plus 4ab plus 2b squared is equal 4b squared is equal 8ab. Then move it to here. A squared minus 4ab plus 4b squared is equal to 0. Then maybe you guys want to ask, how do I know that this thing is equal to this thing? It's because, look at here. A plus b to the power of 2 is equal a squared plus 2ab plus b squared. And a minus b squared is equal a squared plus 2a times negative b, then plus negative b squared, which is equal a squared minus 2ab and plus b squared. So let's see. A plus 2b squared is equal a squared plus 4ab plus 4b squared. Therefore, I change the sign of second term. And if it's not a change, but if the sign of second term changed. So a squared minus 4ab plus 4b squared, it means the sign of the original binomial will change too. So if a plus 2b squared is equal a squared plus 4ab plus 4b squared, therefore a minus 2b squared is equal a squared minus 4ab plus 4b squared. So finally, we get this equation. Both sides, we can square root both sides. So a minus 2b is equal 0. Therefore, a is equal to b. Then we finish the question. So guys, remember, always believe yourself. You see, even though the question looks really complicated, really scary, but all the formula we need is on formula booklet. The things you guys have to do during the test is calm down and sit down and think and do it. Never ever be scared of math, really, because when you feel scared about something, like your mind will tell you that you cannot do it, you are not able to do it, but you can do it. So always be confident. And that's it. Hope you guys enjoyed my math video, and I hope I can see you guys next time. Also, enjoy the math, everything, not just my video, but also everything about math. Yeah, so see you. Even the pen caps have found someone. So which guys are still single?